January 26th, we'll be going over reflections. So a reflection is a flip. If you notice at the very top, we underlined the letters F and L. That is to help you remember that it is a flip because flip starts with FL and reflection has the letters FL in them. So a reflection is a transformation that uses a line like a mirror to reflect an image. So if you notice here, we have a smiley face and it's being reflected. Now this is being reflected across the x-axis. Now it's very important that you remember that this is the x-axis and this is the y-axis when you're transforming, whenever you're reflecting an image. So looking down at the bottom, we have our first rule that helps you memorize how to write an algebraic representation. So this is our first rule. So if you're reflecting over the x-axis, your x stays the same and your y changes. Now we represent a change with a negative sign. It doesn't mean that the value became negative, just that we're representing a change. So this would be x comma y, and it would transform to, we keep x the same and we change the y, so it's represented with a negative. This is how an algebraic representation, when it's reflected over the x-axis, would look. Next, we have a reflection over the x-axis. So it stays, your y stays the same and your x changes. So again, when we're writing algebraic representations, our xy comes first, and it transforms to, we have x comma y, and it tells us our y stays the same and our x changes. Since our x changes, it gets the negative sign. So this is how you would write an algebraic representation if it was reflected over the y-axis. So let's go ahead and look at our first, at the next page. Reflections, page 2. Okay, here it tells us reflect the heart across the x-axis in red. So if I'm reflecting across the x-axis in red, our x-axis is right here. Now, whenever we're reflecting this, what we want to do is we want to position each point the same exact distance away from the x-axis whenever we flip it. So here we have our point here. So it's 1 away from the x-axis. So whenever we reflect it across the x-axis, it should also be 1 away on the other side. And that goes for every other point on that heart. So it should look something like this. Now, if you're doing this on the computer and you cannot draw, you can go ahead and right-click that overlay on that heart. It's going to pop up here. We're going to go down to rotate, and we want to flip it vertically. And that is how it should look whenever it's reflected across the x-axis. So whenever it is reflected across the x-axis, going back to our first page, it told us that first we start off with xy. And it transforms to, it tells us that our x stays the same, but our y changes. To represent that change, we assign a negative sign. Now, that doesn't mean that the value becomes negative. It's just there to represent change. So next, we go on to the arrow. So it says, reflect the arrow across the y-axis in blue. Now, again, this is our y-axis and this is our point of reflection. So my point should be the same exact distance away from the y-axis. So here I have this point. It's 1 away from the y-axis. So I should count 1 away on the other side as well. And that is my new, that's my new point. And then the same here, it's about a half. So a half on that side. And then I'm going to connect my dots. Now, if you were doing this on the computer, to make it a little bit more pretty, I'm going to go ahead and erase that. What you can do is you can go ahead and right-click on that arrow, and I'm going to go to rotate, and I'm going to flip it horizontally now. So this is how your arrow should look whenever you reflect it across the y-axis. Mine didn't look as pretty because it's kind of hard to write with a pen, but that is how it should look. Now, whenever we write our transformation, again, we always start off with xy, and that arrow stands for transforms to. And whenever we're reflecting across the y-axis, our y value stays the same, but now our x changes. So this gets negative x comma y. Now, a little trick is to look at since it's telling us that it's reflecting across the y-axis, I should know that the opposite letter, so that's x, is going to get the change. It's going to get the negative. Okay, so now let's go ahead and go on to the next. So here it says reflect the right triangle across the y-axis in green. So here is our y-axis. So that is our point of reflection. So again, what I want to do is I want to count how many each of my coordinates is away from my point of reflection, and then I'll know how many points I need to reflect it across. So here I'm 1, 2, 3, 4 points away from my point of reflection. So I should count 1, 2, 3, 4 on the other side, and this is A prime. For B, it's 1, 2, 3, 4 away. So on the other side, when I reflect it, it's going to be 1, 2, 3, 4 away, and this is B prime. Next, we have C. It's 2 points away from our point of reflection, so it's going to be 2 points on the other side, and that is C prime. Now, whenever we plot this, if you are doing it on the computer, you're going to take that green arrow, you're going to right-click, you're going to rotate, and you're going to flip it horizontally. And we're just going to go ahead and lay that right there. Okay, so now very quickly, I want you to go ahead and pick the points off of your original triangle. So here at A, we have it at 1, 2, 3, 4, and down 3. So A is at 4, negative 3. B, we have at 4, negative 5. And C, we have at negative 2, 5. This should be negative 4, negative 5. And negative 4, negative 3. Negative 2, negative 5. So now I want to look at my A prime, my B prime, and my C prime. So A prime, we have at 1, 2, 3, 4, and down 3. So that's 4, negative 3. Then we have B prime at 4, down negative 5. So that's 4, negative 5. And then C prime, we have at 2, negative 5. And I'm going to go ahead and retype these in here very quickly. Now, since we reflected it across the y-axis, the rule was that our y stays the same, but our x changes. So I want you to look down here. Our y values stayed the same, but our x changed. So we represent that not necessarily with a negative x. Now, that doesn't necessarily mean that it becomes negative. Remember, that negative sign just represents a change. So this is negative x, comma, y. So whenever we come up here to write our algebraic representation, we start off with x, y, and it transforms to negative x, comma, y. And again, a quick way to remember this is it's telling you that it reflects across the y-axis, so you should know that the opposite letter gets the negative sign. So next, let's go ahead and reflect the right triangle across the x-axis, and we're going to do this in orange. So and since we're reflecting it across our x-axis, this is our x-axis. So starting with my A value, it's 3 below our x-axis. So whenever we flip it across the x-axis, it should be 3 points above it. So that's 1, 2, 3. And here we have A prime. Next we have B prime. It's 5 below, so it should be 5 above. Next we have C prime. It's 5 below, so it should be 5 above. There we have C prime, and I'm going to connect my dots. Now, if you're doing this on the computer, you're going to go ahead and right-click on your triangle. You're going to press rotate, and we're going to flip this vertically. And then I'm just going to go ahead and lay it right there. Okay, so I'm going to keep those original points there. And now, again, I want to find A prime, B prime, and C prime. So for A prime, we have it at negative 4, 3. Next, we have B prime, and that is at negative 4, 5. And C prime, we have at negative 2, 5. Now, looking here, I see that my x values stay the same, but my y values change. So whenever And again, that applies to the rule. So the rule again said that if you're reflecting across the x-axis, your x value stays the same, but your y changes. And again, we represent that change with the negative sign. So here our algebraic representation would be x comma negative y. And I'm going to go ahead and type in our new I'm going to type in a prime, b prime, and c prime very quickly. So we have negative 4, 3, we have negative 4, 5, and we have negative 2, 5. Okay, let's go ahead and go on to the next page. So here it tells us reflect rectangle ABCD across the x-axis. What is the algebraic representation? So since I'm reflecting it across the x-axis, here's my point of reflection. Now, so here I'm going to start off with A, and A is 3 above, so it should be 3 below. So that's 1, 2, 3, and here we have A prime. Next we have B, it's 3 above, so it should be 3 below. There's B prime. Then we have C prime, it's 1 above, so it should be 1 below. We have C prime. And D is 1 above, so it should be 1 below at D prime. And now I'm going to go ahead and just move this down. Okay, so now I'm going to go ahead and pick a point just to show you which value changes. I'm going to go ahead and use point A. A we have at 3, really quickly, I do not suggest if, for instance, A is at 3, 3, I wouldn't suggest using that point for any type of transformation just because you can't follow which point or which number is changing. So we're going to go ahead and do D. We're going to do D is at 3, 1. So D we have at 3, 1. And for D prime, we have at 3, negative 1. Now, our x values stayed the same, but our y values changed. So to represent that change, we're just going to tag on a negative y. So this starts off with x, y. It transforms to x, comma, negative y. So here our answer is going to be D. Now again, we could have seen that we're reflecting across the x-axis, so that's telling us that our x value stays the same, but our y changes, so we should have picked D again. So looking at number 3, it says if xy is reflected across the x-axis, what is the algebraic representation? Write the original and new coordinates for t, y, and r. So first, let's go ahead and start off by getting those points. So for t, we have it at negative 1, 2. Y is at 2, 2. And again, whenever it comes to reflecting or doing any type of transformation, never do a double. So 1, 1, 2, 2, 3, 3, any number you don't want doubles there. And again, R we have at 3, 4. Okay, so now I'm going to go ahead and reflect it, and we're reflecting it across our y-axis. So again, our y-axis is right here. Okay, so I'm going to go ahead and plot our new points. So T, we have 2 points above our point of reflection, so it should be 2 points below it. So here we have T prime. R, we have 4 points above, so it should be 4 points below. So that's R prime. Y, we have 2 points above, so it should be 2 points below, and that's Y prime. So there is our image reflected. Now, if you're doing this on the computer, you're going to go ahead and right click, you're going to rotate, and you're going to flip it vertically. And you're just going to drag it down. Okay, so now T prime we have at negative 1, negative 2. So negative 1, comma, negative 2. Y prime we have at 2, negative 2. And R prime we have at 3, negative 4. Now I want you to go ahead and look at our points here. I would either suggest looking at your T's or your R's. I'm going to go ahead and look at my R's. So if I look at R, I notice that my X values stay the same, but my Y values change. My 4 became a negative 4. So to represent that change, again, I'm going to include that negative sign. So here, my transformation rule would be X, comma, negative Y. Now again, this applies to the rule we learned on the first page. If you're reflecting across the x-axis, your x stays the same, but your y changes. So let's go ahead and look at the next page. Here it says pentagon ABCDE is reflected. What is the algebraic representation? So to me, it seems as if our image is reflected across the y-axis. I know that if it's reflected across the y-axis, my y stays the same, but my x changes. So that alone is telling me that C is my answer. However, if you did not know that, I'm going to go ahead and I'm going to look at my C's. And so from C, I have, that point is at negative 2, 4. And we have C prime at 2, 4. Now looking here, I see that my x value changed, so it should get a negative x, but my y's stayed the same. So here again, we get the same algebraic rule there. So C is our answer. So all in all, in the end, if you're reflecting across the x-axis, your x stays the same and your y changes. So remember, whatever you're reflecting across, the opposite letter changes. It gets the negative sign. And if you're reflecting over the y-axis, your y stays the same, but your x changes. So again, we represent that with the negative sign. Now, again, the negative sign does not mean that the point became negative, just that it represents a change.